Hello, everyone. Today we are starting chapter 4. Again, I did separate it into 2 packets. So this is packet number 1, which will take us through the first 4 lessons, which will actually be about 6 days or so. Then we'll review and we'll have our first quiz. And then after that, you'll get your next packet. So today's lesson is on graphing systems of equations. So the first thing I want to do is I want to mention up here that a solution to a system is a point that satisfies both. Both equations, because the systems we're going to talk about only have 2 equations. So when I'm solving a system graphically, that's one method of solving a system, is you graph the equations on the same coordinate plane. And then after we graph them, we look for the intersection, because the intersection is the solution. So if I graph each system, determine the number of solutions that it has. If it has one solution, name it. So if I graph x plus y equals 2, how I'm going to graph that is I rearrange that so that by subtracting x from each side, so I have y equals 2 minus x. And then this one I'm going to subtract x. And then also divide by -1. So that gives me y equals x plus 4. So I graph that first one by having a y-intercept of 2 and a slope of -1. I get this line here. I graph the other one. It has y-intercept of 4 and a slope of 1. And I can see that these cross at the point 3, -1. So the graphs intersect. Therefore, there is one solution. And that solution is 3, -1. I need to check this estimate by replacing x with 3 and y with -1 in each. So I rewrite my equation, x plus y equals 2. I do 3 plus -1 equals 2. And that does check. Then I do x minus 4, substitute 3 and -1, and that does equal 4 as well. Therefore, the solution is 3, -1. Letter B, I want to graph both those. So the first one has a y-intercept of 1 and a slope of 2. And then the second one, to graph, what I do is I divide everything by 2. And when I do that, you may notice that I get back the exact same equation, which means when I graph it, it's the exact same line. So these 2 lines coincide. Therefore, there are infinitely many solutions. So let's do one through, and I'm also going to show you how to do it on your calculator to check your answers. So number 1, y equals -2. Y equals -2 is a horizontal line through -2 on the y-axis. The other equation, I could graph it using my x and y intercepts, or I can solve it for y. So I'm going to add y to both sides. So that gives me 3x equals y minus 1. I add 1 to both sides. And 3x plus 1 equals y. So that has a y-intercept of 1 and a slope of 3. So that's down 3, left 1. Down 3, left 1. And I get this line, which I should always label both lines. It's absolutely a must because I need to know which line is which. So our directions say graph each system, determine the number of solutions. So this has one solution. If that has one, name it. So our solution is this point right here, which is -1, -2. Now, I can show you how, when they're both y equals, I can check it on my calculator. So I'm going to pull up my calculator. I'm going to go to y equals, and my one equation was -2. The other equation was 3x plus 1. Now there's a couple of things I can notice about this. When I graph it, I can see that they intersect and that there's one solution. I can go to second table and I can look in the table to see where the blue and the red number are the same, which means there they have the same coordinates. So that shows me -1, -2. However, your calculator will actually calculate the answer for you as well. So to do that, see how above trace it says calc? So I want to use that. So I'm going to do second trace. And then what I'm looking for is option 5, which is the intersection. So I can get to option 5 by using my arrows down to 5, or I can just push the number 5. So this says up top, first curve down there. So yes, the blue one's my first curve. The red one is my second curve. Guess doesn't really matter. And then it tells me my answer is -1, -2. Now on a test, you have to show me all your work. However, that's an easy way that I can check my solution. So I want you to pause and try 2 and 3, and then come back and check. Okay, so number 2, I graphed x equals 2, which is a vertical line. And in fact, my calculator won't graph x equals 2, so this one I have to do by hand. And then the second equation, I subtracted 2x from both sides, so that gave me y equals -2x plus 1. So y-intercept of 1, slope of -2, so that's down 2, right 1. And they intersect at 2, -3. Number 3, y equals 1/2 x has a y-intercept of 0 and a slope of 1/2, so that's up 1 over 2, up 1 over 2. My line's a little off here. And then here, I subtract x, I get y equals -x plus 3, has y-intercept of 3 and a slope of -1, and they cross at 2, 1. So now for number 4, if you notice for 4 and 5, both my equations are in standard form. I could go back and use my x and y intercepts because I think that's sometimes easier when they're in standard form. So I'm going to do number 4, reminding you of your x and y intercepts. So it's 2x plus y equals 6. To find my x-intercept, I replace y with 0. So that gives me 2x equals 6, so x equals 3. So that's the point 3, 0. To find the y-intercept, I replace x with 0. So that's 2 times 0 plus y equals 6, which gives me y equals 6. So that's the point 6, 0. And there is that line. To do the other equation, again, it's 2x minus y equals -2. So to find my x-intercept, I replace y with 0. 2x minus 0 equals -2. 2x equals -2. Divide by 2, x equals -1. Then to find the y-intercept, I make x 0. So it's 2 times 0 minus y equals -2. Oops, I plotted that point wrong. Sorry. X is -1. And that gives me negative y equals -2, which means y equals 2. So then y equals 2. I plot that. And you can see that here, I really need to be careful about my lines because my lines are so long that my intersection should have been 1, 4. And mine's just off because my purple line isn't exactly straight. So let's see if I can actually use the shape tool. That would have been better to give me a straighter line. There we go. Better. So I want you to pause and do 5 and 6. Okay, you can see that I graphed number 5 using my x and y intercepts. And it looks as though the lines are parallel. So if I remember, if I look at this, the slope of number 5, the first equation, is going to be -3/2 when I solve for y. And the slope of the other one is -3/2. Lines with the same slope are going to be parallel, so there is no solution to number 5. Number 6, it appears as though I only graph one line because they are exactly the same line. So number 6 is infinitely many solutions. I can't say all solutions because the solutions are only the points that are on the line. So it's infinitely many because there's infinitely many points on the line, but it's only the points on the line.